Hello, I'm Julius, and today we are going to learn about single phase AC motors. There are different types of motors. We have three-phase motors, we have single phase motors, we have DC motors, and we have AC motors. Under AC motor classification, we have three-phase motors and we have single phase motors. Three-phase motors usually are self-starting because they have a rotating magnetic field. But in the case of single phase motor, they do not have a rotating magnetic field, therefore single phase motor are not self-starting. For that matter, single phase motors require an auxiliary or an external or an additional circuit for it to start rotating. Normally it can be a mechanical, there is a mechanical way of starting the single phase motor which is inconvenient and not efficient. Therefore, most single phase motors have a capacitor in the circuit for it to start rotating. There are different types of single phase motors, as we can see in this diagram here. For instance, we have the permanent split capacitor motor, we have the capacitor start motor, we have the capacitor run motor, we have the resistance split phase motor. We also have a shaded pole motor, although it's not shown in this diagram here. But today our major focus will be on capacitor start motor and the capacitor run motor. The capacitor start motor and the capacitor start motor and the capacitor run motor each require a capacitor for the motor to start rotating. The difference between the two is that with the capacitor start motor we have a single motor which is in series with the start winding or the auxiliary winding, and for the capacitor run motor we have two capacitors. One, the start capacitor is in series with the auxiliary or the run or the start winding, while the run capacitor is in parallel with the run winding. Okay, how does this operate? As we said earlier, you need a rotating magnetic field for the motor to start rotating, and for single phase motor this is not possible, hence the need for a capacitor. Therefore, for single phase motors they have two windings. We have the start winding and we have the run winding, or this is the main winding and the auxiliary winding. The purpose of the capacitor is to increase the torque and allow the motor to be cycled on and off rapidly as the capacitor charges and discharges. This creates a rotating magnetic field, hence it starts rotating. Once this motor starts rotating and it's up to 75% of this full speed, this centrifugal switch disconnects the start capacitor from the circuit and the motor continues running. For the capacitor run motor, it starts the same way as the capacitor start motor, because we have the start capacitor which cycles on and off at it charges and discharges, and the motor starts running up to 75% of its full speed. Once this centrifugal switch opens, this run capacitor is energized and it continues sustaining the rotation of the motor. Hence, normally it makes the operation of the motor more smooth and efficient, and the motor is gentle and quiet. That's basically how the capacitor start and the capacitor run motor operate. Next, we are going to learn how to wire a capacitor start motor using a capacitor. Normally the capacitor is of a higher value, very high value, to provide the starting torque needed for the motor to start rotating. Hence you will get the capacitor is rated of a higher microfarad. It's a large capacitor for that purpose, but we are going to see that during the wiring of the same. Thank you for now. Welcome back. As you can see here, we have a fan motor. It is a single phase motor from Pabst, and it is rated 230 volts AC, 50 hertz or 60 hertz, and start capacitor of 1.5 microfarads. This is an example of a single phase motor. Normally this particular fan is used for cabinet doors, electrical cabinet doors, for cooling purposes, and it runs on single phase with a capacitor of 1.5 farads. This is the motor we'll be using to demonstrate how to start a single phase AC motor. And here we have our capacitor. It is rated at 3 microfarads, 400 volts, 50, 60 hertz, and this is the capacitor we're going to use as our start capacitor to start our single phase AC motor. As you can see, as I was saying, it is a large capacitor, and it is large because it will provide the required starting torque, which is about 3 to 4% of the normal torque required to start the motor. Okay, now if you go online, you will get the wiring manual and the description manual for the Pabst fan motor. And from that manual, you can see here on the right we have a wiring diagram for the same fan motor. In comparison to our earlier diagram of a capacitor run motor, we can see this wiring diagram is the same as this wiring diagram if you look keenly. And for that purpose, we now conclude that this motor here for the Pabst fan motor is a single phase start motor, which is AC, because here we have the main winding or the run winding, which is here, and here we have the auxiliary winding or the start winding. It's the same as this one, and here we have the start capacitor, which is the same as this one, and here we have the centrifugal switch, which is the same as this one. Therefore, we conclude that this here the Pabst fan motor is a single phase AC capacitor start motor. Here we have the wiring for the Pabst single phase AC motor. The blue line, the blue cable is for the neutral, and it goes to the capacitor, and the brown line it's from live. It goes through the the motor using the blue line. It comes back with the brown line from the main winding. It goes through the breaker, which is for protection purposes. Then from the breaker it goes to the capacitor. From the capacitor with the blue line, it comes back through the neutral. And this wiring is according to the manual of the Pabst. Okay, now we want to test the circuit, but foremost we are disconnecting the capacitor and give it a mechanical starting torque by hand, and we are going to notice that the motor will start running, but it will never attain the full speed. As you can see, the motor is running by giving a mechanical torque by hand, but as you can see also, it is not attaining the full speed. Hence, there we see there is a need for a capacitor to give it a high starting torque for it to attain 75% of its full speed. Okay, now we are going to test the circuit again, but this time we are going to use the capacitor to start the motor, and you are going to notice that the motor will ramp up to 75% of its speed, and even after you disconnect the capacitor, it will still remain running at that speed because the motor has already attained its starting torque, and it's already running in a particular direction. Therefore, the capacitor can be withdrawn from the circuit and the motor will continue running. Now switching on the capacitor. Yes, as you can see, the motor is rotating at high speed. It has already attained its 75% of the speed, and the capacitor can be withdrawn from the circuit. As you can see, the motors continue rotating. Therefore, we have learned that for a single phase motor, we need a capacitor for it to start rotating, because the capacitor gives it a rotating magnetic field. But once the motor is already rotating up to 75% of its full speed, the capacitor can be withdrawn, but the motor will continue running. Therefore, we have seen that one way of starting a single phase motor. This method it's called, as we saw earlier, capacitor start for a single phase motor. It operates the same way as the capacitor start and capacitor run, but for the capacitor run we have another extra capacitor to sustain the running of the motor. For them, it sustains the run winding. Thank you very much. If you have any questions or any comments, please feel free to comment below. Thank you.